Hi, in this video I want to demonstrate Hooke's law. And Hooke's law says that the restorative force of a spring, call that F4, is proportional, directly proportional to the displacement of how much the spring is displaced from equilibrium. And that's equal to a constant, the spring's constant K, which is the constant of proportionality for this proportionality relationship. And what that means is the restorative force is, let's say I have a spring right here, spring scale. The spring is at equilibrium right now. I'm not pulling it, and I'm not compressing it. It's at rest. And if you don't pull it or compress it, it's going to remain at rest, and that's equilibrium. So the restorative force is whenever I pull the spring, there's a force equal to the force that I'm applying on the spring. There's a force pulling backwards that wants to restore it and bring it back to equilibrium. And the displacement is just that displacement. So like, let's say if I displace it, let's say one distance right here, that's one displacement. And if I displace it this way and then bring it back this way, that's another displacement. And that's all equal to a K. That restorative force divided by the displacement is always equal to a constant K. That's the direct proportionality. Direct proportionality is when two variables, let's say this variable and this variable, in a ratio are always equal to a constant. So what that means is, let's say if I double the displacement, the restorative force doubles, and if I triple the displacement, the restorative force triples. Or like, let's say I double the force I'm pulling on the spring with, the restorative force doubles, and the displacement would have to be double the distance, and triple the restorative force, it would have to be triple the displacement. So the way I'm going to do this is, I have two lead balls and a rod that I used from the Cavendish experiment. I'm probably going to make a video of in the future. And these lead eggs, I'm going to get it, one of them, and I'm going to weigh it with the spring scale. I'm going to weigh it with the spring scale. Give me a second here. Okay. And I think it's a bit difficult to get this to focus. So the weight of this little lead egg is about 1.5 newtons. Newtons. Okay. So what I'm going to do is, I have this other egg, and I'm going to prove that this egg has the same mass as this egg. That these two eggs have the same mass. How I'm going to do that, I'm going to put both of them on the end of this rod, on each end of the rod. Okay, they're both on each end of the rod, and I'm going to balance them at the fulcrum point. They're balanced. They're balanced. And if I was to press this a little bit, it would quickly become unbalanced. So we know that these two eggs have the same mass. They have the same amount of stuff contained within them. So that means that they must weigh the same. So if I was to, let's say, whenever I had that first egg, it displaced the spring, some displacement of, like, let's say, it said 1.5 newtons. It said 1.5 newtons on the, it read on the spring scale. But now that I'm doubling the mass, it should double that distance, because I'm doubling the force pulling on the spring. Give me a second here. I'm doubling the force being pulled on the spring, and thus I'm doubling the restorative force. So when I double the restorative force, that distance must be doubled. So let me now weigh both of these eggs with the spring scale, and you should see that distance doubled. Now it's at about 3 newtons. It's at about 3 newtons now. And you can repeat this with other objects, other spring scales. And as far as that goes, that's Hooke's law. So let me actually explain that a little bit more in depth. So let's say I doubled the restorative force. So when I double the restorative force, it doubled the displacement. That way this equals to 1, and the whole thing was always equal to a constant. And if I was to triple it, the displacement would also triple, and that would still equal to a constant. And that's Hooke's law. And as far as that's it, I guess I could say. And I also have an analog for that, for torsions, for like wires and cables and ropes. It's the torque, the angle, the torque and the angle, angular displacement is proportional. And other than that, if you like the video, like, share, subscribe. See you later.